digits other than 0, other digits, are significant. Trailing zeros are only significant if there's a decimal point. So if you look at this number here, how many sig figs are in 500,000.0? Hmm? 7. No, I didn't. Okay. Do leading zeros count as significant figures? No, they don't. So 0.0058 has how many sig figs? 2. Only the 5 and the 8 are significant. 500,000 with no decimal point. 1. Scientific notation is pretty straightforward. What's 6.70 times 10 to the 3? How many sig figs? 3. Those are the 3 sig figs. A dozen. Infinity. Infinite. I'll just put the infinity symbol. There you go. Constants have an infinite number of sig figs. That's this rule. 3.4005 has 5. All right. Rounding. 589999. What are we rounding to? 3 sig figs. 589,999. What does it round to? $590,000. I would write it in scientific notation, like to the 5. Scientific notation to me is always easier for sig figs. 0.002665 to 3 sig figs. Where are the sig figs? Those ones, right? That's all I'm really looking at. 0.2665. So what does it round to? Yeah, so you could do 0.00267, or you could do 2.67 times 10 to the minus 3. And 0.1254. What does that round to? 3 sig figs. Look at these two and look at the one beside it. Does the 4 kick it up? No. 0.00. What's going on? It does that? 125 or 1.25 times 10 to the minus 3. Okay. Is that bringing back memories? Good memories of Chemistry 11? No, not good memories. Okay. All right. What if you're doing calculations? There's only 2 rules. If you're doing calculations, if you're multiplying and dividing, it's the number of sig figs or digits. All right. And if you're adding and subtracting, it's the number of decimal places. So 34.66 divided by 2.8. If you do that on your calculator, you will need a scientific calculator. You get that, 12.378. How many sig figs does my answer need to have? 2. So what's the answer? 12. All right, you take the first 2. The 3 doesn't kick it up, so it's just 12. 9.041 times 10 times 0.21 is 1.89861. How many sig figs do I need? You need 2. So what's my answer? It's going to be 1.9, right? So you look at the 1.8, the number beside it is a 9. 1.9. 5.78 plus 0.005. If we are adding, we're going to get 5.785. I need to have how many decimal spots? 2, right? Because this one has 2. So it's always the least number of decimals. 578. The 5 will round it to a 9. You know, there's actually a rule for the 5s. Sometimes it goes up, sometimes it goes down. You look at the number after the 5. If it's even, if I can remember.
Well, there's no way that makes sense.
I'll look it up. I can't remember. If it's even, it goes up. If it's odd, it goes up, or even goes down. I can't remember. I'll look it up in 1 sec. Give me a sec. We don't have a number, so 579. If you're in scientific notation, 9.1 times 10 to the 12 times 4.2 times 10 to the minus 3. How many digits do we need in our answer? Should have 2, right? So if you multiply those out, you get 3.822 times 10 to the 10. So it's just going to be 3.8 times 10 to the 10. Is this okay? I went through that like at Mach 10. We're good? All right, flip the page and do those questions, please. Okay, naming compounds. Basically, this is how you speak chemistry. If you can't understand how to name or derive formulas from names, this is going to be a really hard course. Okay? So, ionic compounds. What's an ionic compound? Well, there's a definition right there, sort of. Metal and non-metal, but what happens with the electrons in an ionic compound? They transfer an electron, or they rip an electron away, or whatever you want to call it, right? So transfer of an electron.
I meant like sharing as sharing.
Well, sharing is covalent.
Yeah, but I was thinking about like you said like you're sharing it, so you're not like also eating. What? Sorry.
Okay. This is usually a metal and a non-metal. Figure out the formula. So if I said calcium chloride, what's the charge on calcium? 2. Plus 2, right? Does everybody know how to find this on the periodic table? Like if you go to data booklet, you all have a data booklet? Here's your periodic table. What's the charge in the first column, the alkalis? Plus what? What's the charge in the second? Forget about the transitions. Boron. What's the charge here? Carbon is usually 4, right? It could be -4, but mostly it's +4. What's nitrogen? Charge. What's the charge on nitrogen? Okay, what do the charges represent? If I have lithium +1, why is it +1? Is plus gaining or losing an electron? +1 charge. Did you gain or lose an electron? You lost an electron. Why did you lose an electron? You lose 1 electron, it's like a noble gas, right? Beryllium loses 2 electrons, it's like a noble gas. What does everything on the periodic table want to be? Like. It wants to be like a noble gas, right? Because you have a full outer shell of electrons. Remember this? So, boron loses 3 electrons. 1, 2, 3. It could gain electrons, but if it gains an electron, it's 1, 2, 3, 4, 5. Which is easier? Lose 3, right? Than gaining 5. Once you get to nitrogen, is it easier to go this way or that way? That way. It's 3 moves this way. Gain 1, 2, 3. So nitrogen has a charge of -3. Oxygen has a charge of -2. Fluorine, the halogens have a charge of -1. Basically, it's telling you how many moves or electrons you want to gain or lose to get to a noble gas. Now, there's other ones that have different valencies, but for the most part, that's all they're trying to do. So if we have calcium chloride, calcium is +2, chlorine is -1. So, calcium is +2, chlorine is -1. The shortcut method is what to get the formula? What's the shortcut method? Same base.
Whoa.
What's the shortcut method to get the formula? You basically just crisscross them, right? But what are you actually trying to do? You're trying to balance the charges. So you need 2 chlorines, because it's -1, to balance the +2 charge here. The shortcut is just to do the crisscross, right? So you get CaCl2, calcium chloride. When you're naming an ionic compound, it's not, the first name stays the same, calcium, or we'll do magnesium here, magnesium. The second one, you don't say chlorine, you change the ending to ide, chloride. The charges. But you get rid of the positive and the negative. Okay, that's ionic. Are we good? Metal, non-metal. Do we know where the metals and the non-metals are on the periodic table? Let's just make sure we do that. Where are the metals?
Left side.
The left side, basically. Non-metals are here. There's a little step down. We have a periodic table there. You can see the little step staircase going down it. That sort of separates the metals and the non-metals. Metalloids. There you go. When you get close to it, that is correct. Okay. Okay. Ionic group compounds, otherwise known as polyatomics. If you look in your data package, these are ionic compounds that act together. So at the bottom here. Okay. These are your polyatomics. What does poly mean? Many. It's many atoms, right? So chlorates, there's the chloride, chlorite, chromate. You get your one that shows up that everybody kind of forgets about is this. That is acetate, called ethanoate, but you're going to see acetate more than you see that. Also, it's also written like this. There's 2 carbons, there's 3 hydrogens, and there's 2 oxygens. You'll see it written like that too. C2H3O2 to the -1 charge with a -1 charge. That's acetate. This is where you get your sulfate and your sulfite. Okay. Phosphate. Where's phosphite? Does it even have phosphite? Doesn't have phosphite. All right. So you get this data package, right? Okay. So if I'm asking you to name something, we get the data package. So if we're naming these, NH3, if you look on your data package, has a +1 charge. That's ammonium. PO4 is phosphate. And then the +1 and the -3 would switch. You get 3 ammoniums. Just please be careful when you're writing a formula like this to use the brackets. Okay? Because you have 3 ammonium groups. All right? And 1 phosphate group. All right? You don't change any names. Basically, you just pull them off the table, and that's the name. Ammonium stays the same, and the PO4, which is phosphate, stays the same. Ammonium phosphate. Then you get into the multivalent metals, which basically means they have multiple valencies. All right. So iron 3, iron 2, or copper, when you're naming these, you have to use Roman numerals so that we know which copper or iron it is. Okay. The only ones you don't need to really worry about are zinc and silver. What are the charges on zinc and silver? Zinc is 2 and silver is 1. Okay. These are the transition metals. The transition metals are kind of weird. All right. And that's because they have d orbitals and stuff, if you remember your chemistry 11. All right. We don't go into any of that kind of stuff. We don't do the atomic theory or any of that. Okay. And then you have the covalence, where they share electrons. These are the non-metal and non-metal. This is sharing an electron or electrons. I don't write the word electron because I'm lazy, so I just put E with a minus or a -1. But when you're naming covalent molecules, use the mono, di, tri, tetra, penta. What's after that? Hexa. So mono's 1, di's 2, tri's 3, tetra's 4, penta's 5, 6 is hexa, 7 is, if you're doing, yeah, it's hepta. I'm thinking of something else. Hepta. What's 8? Octa. What's 9? Nona. Nonane, if you remember that. And 10? Deca. I don't know. So basically, if you say sulfur trioxide, 3 oxygens. If I say carbon dioxide, there's a carbon, there's 2 oxygens, CO2. You don't have to worry about the charges when you're naming or covalent compounds. And you don't use the word mono in front of the first one. So if there's, you don't say monocarbon dioxide, you just say carbon dioxide. The only time you put a prefix in front of the first one is if you have 2. So if you have P2O5. What's the name of P2O5? Diphosphorus pentoxide. Whoops. Okay. There's 2 phosphorus and there's 5 oxygen. Okay. So that's the only time you don't. If there's one of the atom or the atoms there, don't use the word mono. And then diatomic molecules. That's Brinkelhoff. Remember Brinkelhoff? All right. So they always occur as a diatomic. So bromine is always Br2, iodine is always I2, nitrogen is N2, chlorine is Cl2, hydrogen is H2, O2, F2. Brinkelhoff. Okay, so if I say oxygen gas reacts, don't just put 1 oxygen. It's O2. Okay. And then the last thing, we're doing like 3 days or 4 days of naming from Chem 11 in like 7 minutes here. The acids. How do you know if you have an acid? Starts with an H. Okay. So if it's a binary, which is usually hydrogen and just an element, HBr, it's hydro, the atom name, but you change it to ic. Hydrobromic acid. What's HCl? Hydrochloric acid. What's HF? Hydrofluoric acid. And then the polyatomics, there's a little rule with the polyatomics. Okay. If the original name ends in "ite," so if you look on your data package, here's the polyatomics. If we end in "ite" right here, it's ending in "ite." So if I had H2SO3, we know that's an acid because it starts with hydrogen. Okay. SO3, you look on your table, SO3 is there, it's "ite." You change "ite" to "ous," O-U-S. So this is, whoops. Oh my gosh, I can't. It's sulfurous. I can't spell.
It's okay, I will.
Why can't I spell? I'm just gonna use. There we go. Sulfurous acid. If it's 8, so if it's H2SO4, ends in an 8, you change it to ic. So this is sulfuric acid. Hello? Yeah, she's here. Sure. Okay. They want to talk to you in their careers. I don't know. I'm almost. You can wait like 2 minutes before I finish this. All right. So 8 changes to ic. 8 changes to ous, which is right here. 8 goes to ous. 8 goes to ic. Okay. So what would this be? H3PO4. And you don't put any hydro. PO4, so find it on your table, is right there. It's phosphate. You change the 8 to ic, so it's phosphoric acid. Ugh. Oh, acid doesn't have any. Okay. And just as an aside, people, they're only called acids when they're dissolved in water. Okay. So I'm not going to ask you this, but HCl in pure form is actually a gas. How would you name it? It's not an acid if it's not in water. It's hydrogen chloride. Okay. That's hydrogen chloride. You dissolve it in water. AQ, remember AQ stands for aqueous. Then it's hydrochloric acid. And that's why HCl gas is very dangerous, because if you inhale the vapors, it dissolves in the water in your lungs, turns into hydrochloric acid, and then that's just not good for you. Okay?
I was really looking forward to it.
Well, we can do that experiment if you want. All right. All right, your job is to start naming compounds, peoples. Okay. The mole. You can't get away, if you're going to do chemistry, you can't get away from the mole. What is a mole? What? Just a number? Mole is just a number? I know you're reading that number right there. Let's write down Michaela's definition of the mole. This is Michaela's definition. It's, what is it? What did you say? A number of something in something.
Does that really say something? It's like
That says something. All right. Everybody talks about this. 6.022 times 10 to the 23. Whose number is that? Avogadro's number. What are the units for Avogadro's number? So you can say particles, you can say atoms, or you could say molecules per mole. It's how many atoms or particles or molecules you have in a mole. So if I say 1 mole of chicken eggs, how many chicken eggs do you have?
6.02
That many chicken eggs. That's a lot of chicken eggs. All right? If you have 1 mole of pennies, you have that many pennies. If you have 1 mole of atoms, you have that many atoms. Okay? So the units change depending on what you're talking about. This doesn't change. The per mole doesn't change. These are the things that change. Okay? I usually just write 6.023, but it doesn't. I usually write 6.02 times 10 to the 23. Sorry? You can use whatever one. It doesn't matter to me.
Don't they get a number from like the number of like molecules in like a gas?
So then there's different ways to look at it. 1 mole of gas at standard temperature and pressure. So is how much? What's the volume? Yeah, has a volume of 22.4 liters. All right. That number, 22.4 liters, I'm just going to write it as 1 mole. Oh, yeah. And chemists, because we're so lazy, writing the E is too much work. So we just put MOL. Okay. Saves us a lot of time. All right. 22.4 liters per mole. This is only for gases. Do not use this like a lot of my Chem 11s did for volumes of liquids. It is not volumes of liquids. This is only for volume of gas. Okay? If you have 1 mole of water, you don't have 22.4 liters of water. All right? It's 1 liter of gas is 22.4 liters. And then the other thing, the other formula that has to do with the mole is this. What's capital M mean? Molarity. Molarity is moles per liter, also known as concentration. And you represent concentration with square brackets. So this is where the math comes in, that may be a good thing or a bad thing. I'm not sure. Okay. All right. This is all like conversions. I don't like this because I just write it out, and then if you just think about it and cancel units, everything kind of works out magically anyway. Okay, so molar mass. You're gonna have to do that. You're gonna do this a lot in this class. What is the molar mass? Molar. Yeah. But what does it represent? What does the molar mass represent? The mass of what? The mass of 1 mole of that substance, right? So the molar mass of MgOH2. Magnesium. What's the mass of magnesium? Look on your periodic table. 24.3? So 24.3. How many magnesium atoms are in the molecule? 1. Okay. So times 1 plus. What's the mass of oxygen? 16. How many oxygen atoms? So it's 2 times 16. What's the mass of hydrogen? How many hydrogens? 2 times 1. If you add those all together, you get 58.3 What are the units? Grams per mole. So that means 1 mole of magnesium hydroxide weighs 58.3 grams, or there's 58.3 grams in 1 mole. Okay? Ammonium phosphate. How many nitrogens? How many nitrogens? What's the mass of nitrogen? So it's 3 times 14. How many hydrogens? 12. And they have a mass of 1. How many phosphorus? There's 1, and it's 31. And there's 4 oxygens, which are 16 each. Should get 149. Is that right? Tell me if I'm wrong. Do people agree with me? Yeah? Okay. Hydrogen gas. Hydrogen gas, remember, is a Brinkelhoff gas. It's H2. It's diatomic. It has a mass of 2 grams per mole. Because hydrogen has a mass of 1. All right. Are we okay? Questions so far? All right. So how many grams are there in 2.9 moles of sodium chloride? So this is beginning to get into stoichiometry, not quite. But the way I do these, I think every teacher does it differently. I write down what I have, 2.9 moles of NaCl. And then I want to cancel moles. So you need the molar mass. What's the molar mass of sodium chloride? What does sodium weigh? 23. Sodium is 23. What's chlorine weigh? 35.5. You add those together, you get 58.5 grams per mole. So that's 58.5 grams per mole is what sodium chloride weighs. I need moles of sodium chloride to cancel out. So do I want moles in the numerator or the denominator here? The denominator. So we write 1 mole of NaCl is 58.5 grams of NaCl. And then what cancels? The moles of NaCl cancel. And you multiply these two numbers. 2.9 times 58.5 to get 169.65. Is that my answer? No. Why is that? Yeah, sig figs. How many sig figs should I have? Should have 2, right? There's 2 there. There's 3 there. I should have 2. So what should this be? 170? Okay. Does that make sense? All right. What is the volume occupied by 50 grams of ammonia gas? So it's gas and it's volume. So I just take what I have, 50.0 grams of ammonium or ammonia. Okay. Do we like grams in chemistry? You like it if you're measuring stuff out, but if you're doing calculations, you usually want moles. So how do I get rid of moles? Sorry? Molar mass. What's the molar mass of ammonia? What does nitrogen weigh? Nitrogen is 14. Hydrogen is 3. So there's 3 of them. So it has a molar mass of 17 grams. Okay, now, remember, you can write this either way. I can have moles up top and 17 on the bottom, or I can have 17 up top and moles on the bottom. I need grams to cancel. So what do I want in the denominator? Grams. So I'm going to write 17.0 grams is 1 mole. And I know nobody will do it. Well, I shouldn't say nobody, but a lot of people don't. Put what it is. Because especially when we get into stoichiometry and they get really long, you want to cancel the right thing and it'll tell you if you have the right answer. So if I have this, that's going to cancel, that's going to cancel. That's going to leave me with the units of moles of ammonia. Is that what I want? I want the volume. Volume of a gas. What number am I using? 22.4. This one, that one right there. 22.4 liters per mole. I want moles to cancel. So what do I want in the denominator? You want 22. 1 mole of ammonia is 22.4 liters of ammonia. Which means moles of ammonia cancel. I'm left with liters of ammonia. Everything in the top gets multiplied. So you can do this in 2 stages, or you can do it all at once. You can go, I don't know, calculator. If I go 50 times 22.4, I get 1120 liters of ammonia. The bottom is just 17 because it's 17 times 1. You can do this all in one step, obviously. And then I divide 1120 by 17. 65.882 liters of ammonia. Is that the right answer? What do we have to remember? Sig figs. How many sig figs do I have to have? 3, right? There's 3 there. There's 3 there. There's 3 there. Or I guess there's infinite there, but so 65.9. Okay. Time is class end? 10-2? 7 minutes? So we can do 2 more? 6? Okay, we can do 2 more. We can do this. All right. What is the mass of 1.0 times 10 to the 12 atoms of chlorine? Okay. We have that many atoms. Atoms of Cl. Okay. Do we have something that relates atoms and moles? We got Avogadro's number, right? What are the units on Avogadro's number? It's particles or atoms or molecules per mole. We're going to use the atoms for our units. So we go 1 mole of chlorine is 6.02 times 10 to the 23 atoms of chlorine. Why did I write it like that and not the other way around? Why didn't I have 6.02 up top? Because you want the atoms to cancel, right? Because then I have those cancel, and now I'm left with moles of chlorine. But I don't want moles. I want grams. So what do I have to use? The molar mass. What's the molar mass of chlorine? 35.5. So 1 mole of chlorine has to go in the denominator so the units cancel. is 35.5 grams of chlorine. Cancels. Multiply the tops, divide by the bottom. You should get, how many sig figs should my answer have? 3. You should get 5.89 times 10 to the minus 11 grams. Is that correct? People that did it? I don't know if I rounded correctly.
I got 5.90.
Is it 90? Did I mess up the...
There's just 7 after the 9.
Oh, is there? Okay, sorry. 5.90. Okay, 5.90 times 10 to the minus 11. All right. Are we good with that? All right, last one. How many oxygen atoms are contained in 75 liters of SO3? What's the name of SO3?
Sulfite?
That's the ion. Sulfite is the ion. This has no charge. SO3 gas. What type of molecule is it? Ionic or covalent? Covalent, so it's sulfur trioxide. Okay. We have 75.0 liters of sulfur trioxide. Do I want liters? I want what? You want moles. And it's a gas. Little G symbol there. So we're going to use, there's 22.4 liters of SO3 in 1 mole of SO3. Ugh. How many molecules of SO3 are there in 1 mole? Avogadro's number. There is in 1 mole of SO3, there is 6.02 times 10 to the 23 molecules of SO3. So the moles cancel, the liters cancel. I now have molecules of SO3 are my units. Is everybody with me so far? This is important. Okay, what am I asking though? How many oxygen atoms are in that many liters? So the next question is, what do I have to do? There's 3 oxygen atoms per molecule of SO3. So 3 oxygen atoms for 1 molecule of SO3. And then those cancel, and then you multiply across, you divide by 22.4, and you should get 6.05 times 10 to the 24, I think. Oxygen, can't spell oxygen atoms. Okay?